Well, we're back again. This is a second half of January 2 weeks update. And this is the second video because I accidentally deleted 4 videos. Spent all day trying to get them back. Can't do it on a Samsung. It's a Galaxy Sky Pro J7. Can't get to the recycle bin. Tried and tried and tried. I don't think there is one. Anyway, here we see Nene loading the mixer up. And Benji is pouring a concrete bottom lintel. Let's see here. Well, that's not so awful bad. That's so we can have a step up into the bathroom, which is also on the other side, is a better than 2-inch step down, required by Philippine law. We can't get power connections and such if we don't do that. And Nene and Al, they're catching some concrete, going to pour it. You can't quite make it out, but what we got here is we got 1, 2, 3, 4, 5, 6, 7 strings going south on the bottom to the north on the top. And we got 3 strings, 1, 2, 3, going the other way. And these intersections are where the columns go that holds the solar array. And you'll notice that they flattened this out pretty flat. The box is so they can line up with the intersection of the strings with a corner in the box. And that way the strings will show you if this thing is twisted around, and make us foundation pads that are the same shape, same load bearing. This is a picture of I guess Boyette's day. He cut tie wires. And here they are. He's marking the shape, digging down about 2 or 3 inches. And they're digging these things out. They'll pick this dirt up and pile it somewhere else. It won't be left there to get wet and run right back into the job site. I think you can see the grid lines more now. This is about the same point in time. He's still on that same hole. He's moved over 1 hole. And everybody else is taking dirt out of holes. Okay, we've switched up people a little bit. I'm not sure what this white stuff is. It used to be green. But I'm glad they switched to that white plastic because you can see it better. And here we are, taking dirt out of the holes. This is going to go on for a while. Oh, this is some kind of a like an aloe plant that she's trying to multiply. They're multiplying some other stuff here along the sides of the dirty kitchen. This dirty kitchen is slip form poured. Done in 3 pours, 4 foot, 3.5 foot, 3.5 foot, and it's got 3 window bucks on each side with a jamb, and a door jamb on each end. This is for flow-through ventilation. That's the direction of prevailing winds is from the far side of the building out through these windows. Kitchens tend to get hot, so. We got a lot of holes dug now. We're working on 21 holes, so they're well along, and they're starting to bring down the some bags of sand and cement. We pre-stage everything, so all they have to do is throw it in the mixer, and then normally, and I think we'll do it this time too. If we have my druthers, we'll lay a couple of pieces of phenolic board across the top of the rebar. And it probably will go that way, left to right. We'll set the mixer on that, and then they can just dump the mixer over and dump it out, and we move the mixer along, and that saves a lot of carrying cement. So these are on them. These are on our pocketbook because we don't need 21 people. We only need about 7 to pour these. We're going to pour this floor in thirds. It's around 71 bags of Portland cement, so there'd be 142 sand and, let's see, 213 bags of gravel, 3/4 inch stone, basically. We use that black gravel. It's like about hard as obsidian. You try to smash it with a hammer, you don't have much luck. And we're throwing dirt. They've dug these holes. This is the second day of digging on the holes. The first day was laying out strings, and they dug like 2 holes. And this is showing you how straight that they dig a ditch in the Philippines. They put a piece of string down or up or wherever, or fishing line, and they can dig you a septic tank or anything else, or concrete piers, and they're perfectly straight up and down. And we have some really crappy dirt, so it doesn't make their workmanship look as good as it really is. And plus, it's bone dry down 9 or 10 inches right there, so they have to chip it away. It's miserable work, but they're glad to be working every day while we're not there. Oh, this is the tilapia tank back here. It's 3 feet out of the ground. All the other ones, I don't know if you can see up here in the corner, the floor of them is flush with the ground. Okay, they've gone to a homemade mix box here. They're going to dump the mixture into that because what they're doing is they're putting concrete in these holes. Let's go to one with a picture of a hole. Okay. They put a old cement bag down there to keep the cement and water from going into the ground. And they're supposed to have a piece of rebar or a piece of bamboo or a piece of plastic pipe drove into the bottom of the hole to a depth set by the water transit. That's that plastic tube they use for a transit level. They like it better than my K&W optical transit. And when I get the laser transit out, I'm sure they'll go to that. But right now, they still like the plastic tube. And you notice that there's not a lot of water floating on top of this. And they have troweled it off. It's fairly flat. And this is so that we can start off with a common depth. And then when they set their tree, that's that rebar thing that you've seen in the previous video, they can get them all turned where they, where they're in a line, because they're square. You don't want them sitting at 45 degrees. So they'll be able to slide them around and left and right and back and forth and twist them and get them all in rows, which is important because we're going to put a solar panel array on top of this, and glass doesn't bend. Glass bends. Glass is actually a liquid. It's not a solid. So it does bend, but it takes a long time. Is that a different hole? Yeah, that's a different hole. And you see how the earth cracks, it's so dry. We pour our concrete anytime we can on dry ground, because we use polyethylene to keep the water and cement from going soaking into the ground. And we never pour concrete on gravel or sand, because all your cement and water, the bottom half of your concrete, goes right into the gravel. It's not in the concrete anymore. You get stones down there. The top stuff doesn't migrate quite as bad, so it looks like it's concrete on the top. But when you go to jackhammer it up, you'll find the bottom is just mostly stones. And when it went into the form, it was exactly the same. But if you pour it on ground that the water can go into, then that's where the water and cement's going to go. The reason we pour on dry ground is because the water will come up. Once you cover this dirt, the water will come up from the lower, 5-6 feet down. It will dampen this dirt, and those cracks will close back up, and the dirt will swell, pushing it up against the bottom of the concrete. It sounds tight when you hit it with a hammer, like it rings. And if you pour it on, the alternate way they do it over here is they flood it with water and soak this ground so that the water and cement doesn't go into the ground. But that will have a higher hydration than the natural dampness. So the dirt will shrink back a little bit. It's like potter's clay, It'll shrink back some, and it won't be tight against the floor. So you have to use a lot more rebar to get the same strength out of your slab. And I see plastic bags in several holes, and they're going right along. I see plastic bags in a lot of holes. Let's see. I don't know if we looked at this before. This is the edge of our toe kick. There's two pieces of it here. And that's under the kitchen counter. That's the shape of the counter. It's got that curve in it. 3 curves, actually. Curve in, curve out, curve in. And that's because we wanted the countertop wider than the space where he's standing between this joint here that you can't quite see. It's faint. That's actually a column. The columns all stick out into the rooms because the walls are 7 inches thick, but the columns are 30 inches by 32. Actually, I think they're 32 by 35 for what we actually ended up with. So this piece here is not as wide as we wanted for the counter, because we're putting a bunch of burners and woks and stuff in there for sinks, and plus we have to have a place to actually put things. What he's leaning on back here, that is the kitchen counter, but the toe kick form is out here. This is a bathroom. This is my wife's bathroom. It gets a toilet, a vanity sink, and a bathtub, a soaking tub. She really wants a soaking tub, and that's fine. She gets what she wants. I mean, we're doing the house she wants. She may as well have a bathtub in it. This black here is phenolic board. It's just a box of phenolic board. And when we put the 5 inches of cement in the bottom of this and make a shower tray out of it or whatever, actually it'll just be a drainage for cleaning the bathroom, because the shower is on the other side of that wall. Uh-oh. Yeah. But that lets us run pipe back and forth if we need to interconnect something. I don't think we do. This is showing slip forms piled up. That's what they look piled up. This is what they look like if they were standing up where you could see them. And these facings can be flipped over to use this second side, which is basically on the outside. After about 26 pours, you unscrew them. Take a 2.5 millimeter cobalt drill, rattle it around in the hole in the screw head. You can use Allen heads. We use Torx heads. But anything that's got a depression in it, you just rattle that bit in there in a high-speed, like 1/4-inch drill. Then you turn the drill 90 degrees and blow the dust away, and the screws come right back out. Now, we dip our screws in motor oil before we screw them in to make them easier to screw in, because we use what they call Goodwood. It's like trying to use white oak or something. Not real receptive to screws. And we pre-deal the phenolic board. One of them is a pattern for the next 50 or 60 you make over a couple of years. So they're all identical. They all interchange, and they can all be flipped. This will be my wife's, what do you call it, wardrobe. She uses like a piece of inch galvanized pipe across the top, supported off the ceiling, and chains hanging down, pintle chain. It's like you think of chain in a hardware store. And she hangs her hooks of her clothes in that chain, so they all just lay flat on top of each other, like in stacks. And she's got a hook like you take fan belts down in an auto parts store, you know, on a stick. It's like a wooden stick with a hook on the end. And she can lift off clothes out of that stack. And she'll put around 1,500 pounds of clothes in this wardrobe. Most of the stuff that's the season she's living in. These are the rebar stands. And, well, that is the top of the picture. Changing the camera will not make the picture taller. How about that? Anyway, you can see that the legs are fanned out. There's 8 legs that it sits on. And these will be sitting on those concrete pads down in the hole. And we have stirrups that are the spacing is the outside of the square column or less. It can't be any bigger. That's a code item.